So Victor from Nanoplus reached out and was kind enough to provide some feedback on the thermal design. It occurred to me that I wasn't doing a good enough job on the assembly and how this thing is being put together. So here we have the laser. It's just a dummy model for the laser. And so here we have the PCB. It's guided by these dowel pins, and there's these bosses that create the flat surface for it. So there's no direct connection from the PCB to the laser. What is in contact with the laser is this, what I'm calling a heatsink plate, essentially, and the fixture. So direct contact, this is going to screw in with some 440 screws. And so the idea here is that when we look at this cutaway, the problem here is that there's a small annulus where the base of the TO5 can sits, and essentially where the center bore of this thermal plate sits. And so that, the TO5 can base is probably something like 9.5 millimeters, and I think this is 6.5 millimeters. So there's a tiny annulus that does the actual thermal contact. Now I'm going to put in some thermal paste here to help with that thermal contact. But the idea was, okay, well, ideally I'd create these through holes on this heatsink, insulate them somehow so that there's no electrical contact between the pins and the heatsink. But then, this pin is on the order of about 0.45 millimeters. So tiny pins. And so that'd be tough to do on my machine. So I got to thinking, well, even if I were able to, make some pins and add a little bit of extra seating surface for thermal contact, I don't really think it would benefit much. And primarily, let me walk through why I think that's the case. Okay, so here's a simplified diagram of the section of the assembly. And so we've got this is essentially that fixture base. We've got the TO5 can here, and then this is that heatsink portion. And so this is that thin annulus where the contact is actually happening. And so if we think about this from heat transfer, where's the heat going? And so it's going from the can into the heatsink plate, and then probably coming out into ambient here, but also primarily, I think, if I want to try and simplify this down into a 1D chain, we could probably think about this in terms of, okay, there's that interface between the TO5 can and the plate, the thermal the resistance across that plate, back into another interface over here. And what I'm calling cage resistance here is essentially the resistance of the heat transfer from this wall here across the housing fixture base. Essentially it's kind of a little bit of a catch-all in terms of heat going from that cage, the 30 millimeter cage, out into the environment. That's a super simple way of looking at it. And so then I got to thinking, okay, well, if we could add a little bit of area here in the center, would that actually help? And based on some, thermal resistance numbers for the interface. We're looking at, about 0.7 for the plate itself, 6061 aluminum, about 0.4. If I had to go through the interface again, another zero point 0.7 across the cage, probably zero point 0.2. It's a much larger surface area. And so the big one, it turns out, and there's some assumptions that go into, what your coefficients are, but I mean, the majority of the heat transfer that's occurring to the ambient is going to be due to convection. And so that's the big kind of overwhelming factor in this. And so even if I could increase the area, a tiny bit more on that heatsink plate, I really don't think it's going to help. If I assume for the most part, about 40, 41, 40-ish Kelvin per watt of thermal resistance, it kind of turns out that our ambient sealing is kind of limiting us to about 35 degrees C. That's including some, these fins that I threw on the thermal plate. If my garage gets higher than 35 C, likely what I'll just do is probably, I'm just going to turn on a fan and cool it down a little bit. I have it sitting on a bench, so I think that'll be enough to operate it, on a hot day, maybe up to 40 C in the garage. So the main takeaway is how we're dealing with convection to the ambient really is the major factor in dissipating heat here for this heat sink. So that leaves us with slightly more complicated heat sink design. These fins are pretty narrow, so I'll be pushing the limits on the tooling I have for this part, but it'll be interesting to see how well it dimensions and how close I can get to this part. Thanks for watching.